goal is we want to come up with a line in the form y equals mx plus b, right? That's our answer, the equation of the line. And so to come up with that equation, we need to find out what are the values of m and b, right? M is always going to be easy. B is the one that's a little bit trickier. Now, what can we say about m here? If our line, and let me draw the line. The one that we're trying to come up with is the one that goes through point P that is parallel to this line. So the blue line, the equation of the blue line is what we're trying to come up with, right? Make sense? Okay. How are we going to find its slope? Somebody raise your hand. Okay. Rise over run. Okay, but I don't want to trust this line that I drew. In fact, I'm going to erase it. Okay, that line, that's the one that we're trying to find. But we don't have that line to use because it's not graphed for us. So how are we going to find the slope then? Okay, because the lines are parallel. And what do you know about the slopes of parallel lines? They're the same. Good. So let's just find the slope of this line. Somebody, raise your hand. Somebody give me a convenient point I can use to make my slope triangle. Yes, sir.
0, -4.
Okay, 0, -4. Keep going. And
3 and -5.
Okay, 3, -5. Everybody see that? I could write those coordinates down if I want to and use the slope formula. That'd be fine to do. But I could also, being as I happen to have a graph here, why not just use a slope triangle? Okay. Now, which point do I start at? This one or this one? First or second? Left. Got to go left to right with a slope triangle, always. So we're going to start here because it's left. And then to make my slope triangle, I'm going to go vertically first. Do the rise, slope is rise over run, so let's do the rise first. What's my rise going to be? -1. I'm going down 1, so the rise is -1. What's the run? So then the slope of this line is what? Yeah, -1/3. Does that make sense? Does this line look like it has a negative slope? Yeah, it's falling, isn't it? If it was a rising line, it'd be positive. Falling line is negative. So that seems right, doesn't it? Okay. So there's half of the problem. I got M. Now I just need to find B. B is the trickier part, though. There's a little bit of algebra involved in finding B. So to find B, somebody raise your hand and remind us what's our strategy for finding B.
You use the coordinates of B that you put in for X and Y.
Okay, X and Y, and then we know M. Good. So we need to be able to plug in. If I want to solve for B, I've got to be able to plug in values for everything else, right? Now I found M, so I know that M is going to become -1/3. But what about X and Y? Well, I have to use the coordinates of a point that is on my line. And remember, the only point that we know of that's on the blue line that I drew is P. What are the coordinates of P? Okay, but, okay, 1, -2. We got to go in order, X then Y, right? So the ordered pair is +1, -2. So what's going in for Y then? -2. What's going in for X? 1. And then I'm just trying to find B, right? Okay, so there's my algebra equation. All I got to do is just solve that algebra equation, right? So what do I do to, I'm going to make a little, give us a little room here, so just kind of work over here doing our algebra. Talk to me about solving that. It's something I probably want to do. Okay, good. Multiply 1 times -1/3. What's 1 times -1/3? -1/3. So I'm going to get -2 on the left side. The product of those two numbers is -1/3 plus B. Okay, now somebody else, raise your hand, please, and tell me, what do I do to get to B by itself? Good. Add 1/3, right? Did everybody see why? I have to do the opposite of, I have to undo adding -1/3, which I would do by adding +1/3, right? The other way I could think about it if I wanted to is subtracting -1/3. Okay? Same thing as adding 1/3. So if I add 1/3 to both sides, got the b by itself. But what do I get on the other side? I get -2 plus 1/3.
5/3.
Okay, now let's talk about how we can get that.
That's what I said.
You're right. Let's talk about how we get that. So if I've got -2 plus 1/3. Now you can do this on a calculator, that's fine. If you have a calculator available, I can just treat the fraction, put it in parentheses, and it's going to give me back an answer. But what if, how can we do it without a calculator? Let's just remind ourselves, if I'm adding up fractions, first thing is, we want to make both of those look like a fraction, right? So I'm going to put a 1 on the bottom of the -2. But when I'm adding or subtracting fractions, what do I have to get? Common denominator. What's it going to be? 3. Okay, so what do I multiply the bottom by over here to get 3? Got to multiply the top by the same, right? Okay. So what's this fraction going to be then? -6/3 plus 1/3 is how many thirds? Good. Okay, because Eric, the reason we do that, right, is because if we're adding and subtracting fractions, the common denominator stays the same, and we just add and subtract only the numerators. Okay. So -6 plus 1, -5, and that was our b, right? What was our slope? Remember? -1/3. Okay. Okay, let me take a pause here. Everybody needs to readjust. Basic purpose.
Just kidding.
This is I want you to really focus on this. If people have a hard time with this stuff, really, I mean, this is not when you got to start putting all this stuff together into one process. There's a lot of steps to that. Once you get it, you won't think it's a big deal, but getting there is a little bit of a process. You've got to get over that hurdle. If you really focus on this today, I guarantee you can get it. You really can. We're going to do a couple examples on your own here when we go to the lab, so you'll get a chance to really just get this ingrained in your thinking. But if you don't get it today, you got to start all over from scratch next time. So just get it. Get this today. So we got M, we got B. Then what's our answer? Yeah, right. We got it. So our answer then is just y equals -1/3 x minus 5/3, right? Okay, we just had to find M and find B. All right, so try this one. Now, I conveniently made the point and the line exactly the same. So we've already done a lot of the work here. We already know that the coordinates of P are at +1, -2, and we also already know that the slope of this line is -1/3. But this time they want us to write the equation for the line that's perpendicular to the black line through P. So if I were to draw it, it would look like maybe like that, right? That's my line. So what's my slope going to be? Let's see, show it here. What's it going to be, Janelle? 3. How'd you get 3? Opposite reciprocal. Opposite of -1/3 is positive, and then the reciprocal part means I flip it. So I'm going to get a slope of 3/1, or just 3, right? So this ends up being actually an easier problem. There's no fractions. So now if I want to find B, what am I going to do? What am I going to do? What do you think, Deb? What am I going to do to find B? What's my strategy? I'll get you started. I'm writing this. What do I do to get that B?
I'll take the coordinates of P.
Good. Good. Take the coordinates of P, plug them in for X and Y, and what do I plug in for M this time? 3. Good. Okay. So then that's going to give me Y is -2, M is 3, X is 1. It's easier math this time. -2 equals 3 times 1 is just 3, right? Okay. So then what do I do to get the B by itself? subtract 3, and I get B is what? -5. So I got B, I got M, what's my equation? Very good. Okay, you think you're ready to give this a try?
Yep.
All right.
Do it, all right.